We have two keynotes for our lunch. Our first keynote speaker is Robert C. Robert is the State Broadband Coordinator and lead for Agricultural Technology and Innovation Strategy at the USDA, California Rural Development. Using his strategic vision, he integrates policies, resources, and initiatives at all levels of government and creates public-private partnerships. And if you know Robert, that's what he does. He creates partnerships because everybody knows Robert, and he's really excellent at doing that. His focus is on improving the economic well-being and quality of life for our rural residents and our food and agriculture sector through new agricultural technology and broadband infrastructure. So please welcome with me Robert C.
Well, thank you, Linda. Thank you for inviting me to come up and speak twice, actually. So my wife says I talk too much, so I'm getting it all out in my system here. But I would like to thank West Hills for inviting me, and I think this is my third or fourth time at an Essential Elements meeting. And before I start, I really want to thank and appreciate the initiative that West Hills has taken not only on this project, but also, if you go back a couple of years, we had the first agriculture hackathon, and I believe ever held in the country, which is developed and held at West Hills. And the first kind, when you have a new idea to try to do something, it's always the most difficult. Just first of all, to convince people that you want to do it. And West Hills stepped in and did it and had the first one. And that is tied to broadband, because all those apps that were developed don't work unless you have broadband in the field, and that's in fact exactly what one of the students from West Hills who developed a winning app discovered, that the challenge was not the app itself, but that the rural broadband infrastructure wasn't ready for it. So we're probably seeing more of those type of things going on right now. So I'm going to go through and sort of quickly, I thought I would, because you already heard all these various pieces of broadband, and what I want to do is go through and talk a little bit about the future and agriculture technology and how it might fit in. And first of all, I like to set the stage because I am an economist, and for Dennis, I once did a 150-slide presentation over 16 hours with the Oregon Ag Department when I was doing international trade for the Foreign Agricultural Service. So since I don't have 16 hours, there won't be that many slides. But first of all, as I think you all know, that California, if you start with California, it is the leading ag producing and exporting state, $54 billion of farm gate. I think that's 2015 numbers, and about $22 billion in exports. If you drill down, the San Joaquin Valley is the source of most of that. 60% of the farm gate of California is produced here in the San Joaquin Valley. And if you drill down some more, the West Hills College four-county area of coverage into Fresno, Kings, Monterey, and San Benito County is about $13.8 billion. And I realize the district is smaller than the four counties, but that's the four counties you're affecting that. And even if the two-county part, Fresno Kings, is $8.6 billion, for contrast that you should know, Washington State total is $9.1 billion. So you have to figure out where you sit in context of this. And the other way to look at it is the food value chain, because for this area, you're the center of it. You're the epicenter of the food value chain of California, the red circle over there. So the rest, downstream, going all the way to the consumers, would not exist unless you didn't have the ag production here. And that total for the state is upwards of $142 billion in economic impact. So there's a multiplier of maybe 3, and that's an understated multiplier. So you give an idea of the impact of what we're talking about. You've seen this chart before, but I always like to use it because basically, my point is that the platform for rural prosperity in the 21st century is rural broadband. That chart has all the layers on there of the different pieces, which you've heard people talk about. You've heard about telehealth. the importance of that, all the different slices in there. I'm going to show you, we talk about the farm of the future, and I think a lot of these things, it's easier, rather than talk about it or read numbers, is actually just to show you a nice graphic or photograph of it. This is a nice graphic or drawing that actually shows the next generation farms. And within that, all the pieces of ag tech going all around, predictive ag and predictive analytics, marketplaces, robotics and drones, sensors, smart irrigation and chemigation, wearables for animal and people. What I might say about that is that's maybe one of the new things coming, animals and people. So the wearable for the cow and the wearable for the person would actually, the way it works, would tell you when either the person or the cow is getting sick before there's actually evidence from just looking at the person, so you could respond earlier. And so you would actually save resources by treating earlier. Less antibiotics would be needed for the cow, and also you can pull the cow out of a herd to prevent cross-contamination. For people, there's a workplace aspect of it, so you could actually identify if someone might have heat stroke in the field much earlier and then avoid the health consequences of that. That was there before because Gabe talked about the horse, so I brought the horse back. So ag technology, like the broadband speeds, the farm is not using the horse as its principal use of technology or mechanization of the time. I know that the public, the general non-ag public in the coast, probably still believes that is the state of ag technology. And since we're in California, I always pick on New York City, and I said that's what I'm sure New Yorkers think of what it is. Another way to look at it is this is all driven by data agrolytics, and I would coin that as a new word instead of data analytics. Data agrolytics is the data analytics of agriculture data combined with ag science, combined with economics, and it drives all of these pieces which I already just talked about. You're just seeing it in a different form. I would say food safety. The thing about that is rapid diagnostics, which means real-time decision-making, that there are devices now, they're either out or about to be out, that can actually determine if there is a pathogen that you don't want that's in the field. While the harvest is going on, you get the answer in 3 to 5 minutes. Harvest is taking 20 minutes. You get the information, you can send that information to a decision maker that can come back and maybe stop the harvest. So you avoid all this food safety cross-contamination that goes on nationally. And you also follow and meet the FDA's general inclination to enforce the Food Safety Modernization Act as traced back to the farm. So if you cut it off at the farm level, you're better off with that. I think what we're seeing with this ag technology is actually a change in the whole cycle of development in agriculture. With the Internet of Things on the left and all these ag devices combined again with technology, science, and agriculture, the traditional areas of development, and then mixed into the new areas where ag tech is influencing. And here again, production, which we're talking about really yield, greater yield, water issues, environment, energy, food safety. The newer one is health, and I just talked about the health wearables, but there's other components of that in terms of specifically developing crops or plants that are actually healthier for you, which can be done. All of this cycle then goes into the broadband area to where it is implemented, if you have it. If you don't have it, then there is a costly fix to try to get around that. Those who get there first, I think, will prosper and take advantage of ag technology before anybody else, and will have that advantage. I talked about agrobotics. It's probably better to just take a look at a picture of it. There's an estimate that might be a $13 billion market by 2022. That's probably a low number. There's a picture of a robot in the field. I think the sensors, and the thing about the sensors is you can talk about them, and it's probably easier to conceptualize the relationship between the sensors in the ground, in this case the soil moisture sensors, and the devices that are transmitting the data, and the sort of collection of different types of sensors. It's easier to take a look at a picture. But what you just looked at is actually, I consider it to be obsolete already. The next generation of sensors on the water side and the advanced water side are these leaf transpiration monitors, which UC Davis is developing and testing right now, that actually, the soil moisture sensor, you're getting a moisture reading from the soil, and there's an assumption, there's a pretty good assumption, there's a relationship between the moisture level in the soil and the moisture needs, or the water needs of the plant itself that's next to the sensor. The leaf transpiration monitor skips that and just measures the transpiration from the leaves of the plant and directly tells you what the plant needs in terms of moisture. And this particular device is sensitive enough that it can actually tell you if the sun is falling on this side of the plant, this side of the plant actually literally needs more water than this side of the plant that's in shade. That's how sophisticated that is. And then you can imagine you need to do the algorithms and how to really figure out the minimum amount of water needed. So the savings involved in that. Drones, we heard a discussion on that already. This is an example of a drone that's spraying. What that, if you think of drones, it's a tool that might help in some of that, the conflict that's in that sort of rural-urban or rural-suburban divide, and where houses that come out to the edge of farm fields, you can't fly over with a plane and spray. It's just not going to happen. This, because it's so close to the ground and it's more precise, has the potential of allowing you to continue that kind of spraying a little bit closer than what you can with planes now. And since I have the drones up, and this is an idea, actually you can talk about the pace of change that's happening. Let's see, this would be 1, 2, 3, 4, about 8 years ago, I had a conversation with some engineers from Northrop Grumman. Northrop Grumman makes the Global Hawk drone. The military drones were the first drones. And their question to me, and I was at CDFA at the time, the question to me was, can you imagine any civilian use for drones? That's Northrop Grumman's question. So what has happened since then? That. And actually, that Global Hawk is another thing that it's, the technology that built the Global Hawk was developed in the 1970s. The Global Hawk is actually obsolete from a technological standpoint. So that's how fast we've gone. Again, we talked about robotics, and that is a picture of one of the many different strawberry robotic pickers. That's probably one of the biggest challenges in terms of, I think from an engineering standpoint, of how to pick strawberries that are spread out on the ground. How do you have sensors that recognize which one is ripe? How do you have the picker part that doesn't crush the strawberries when it tries to pick them? So there's different versions of this going on, but that is a direct answer to the other topic of discussion, farm labor shortage. Because that farm labor shortage is not going away, and it's going to increase, and there's a combination of different reasons why that is coming about. So this is a response, at least in this area. But what that then does, and you've already had the discussion, is it opens the door for discussion of, because that doesn't mean there are no farm workers or no one operating any of this machinery. It just means there's another set of technical skills that you need to operate. So the connection, which comes back to West Hills and another side, is how do you train the existing farm workers, or those who want to be farm workers, for the new ag technology farming, so they're the ag tech farm workers of the future. If you don't do it, then you end up with what has already happened in the industrial sector, where you've had this massive long-term unemployment come across the country. And in rural areas, I talked to someone in Pennsylvania, and there were more rural manufacturing jobs than people in agriculture in rural Pennsylvania, and a third of those jobs disappeared over the last 30 years because of automation, and nobody thought to retrain the workers into the changes coming forth. So there's another example of the automated weeder that's actually already here, and then here's the schematic that shows, again, the relationship between the devices and the connectivity, it's easier to look at it. And if you look very carefully at this, you'll see that this diagram is actually the diagram of how broadband is connected to greenhouse production. I'm just going to leave it at that because we're going to get to that in a minute. Again, rural broadband, we've already had the discussion about the impact of regulation and ag technology, and all those R's, water, energy, environment, food safety, and health, are areas where we have huge regulatory requirements. The opportunity of ag technology is this. If you are the farmer and you are adopting that technology for your own purposes, for better yield, better business aspects, those same sensors have the potential, because of the data they're collecting, to meet the regulatory demands, especially on water, like Sigma, for how much water you're using, in environment, if you have to prove the amount of nitrates that are being used. Those sensors have that information, so there's a dual use. So I call it multi-benefit use of the same technology. If you take one perspective on this, if I'm the farmer and I have all these regulatory rules and regulations that I have to meet, and I have this huge cost to meet those regulations, even minimally on the reporting side, and I can't charge more for those costs because of the way the market works. That's a net cost to me, and I'm not happy about it. But if the technology that I'm buying anyway for better farming, for sustainable farming, can meet those demands, and if then at least I'm sort of halfway happier about it, I've met the regulation. So that's one aspect. Our challenge is that the regulatory agencies, they don't know anything more about ag technology or technology than the rest of us on a regular day-to-day do. So your challenge is to make sure that the regulators understand the potential of this ag technology to meet the regulatory requirements, the data needed, and to make sure that when they write the requirements and have it out there, there's a match. So you don't have this extra burden there. So this would actually be a win-win. The regulators get the data and the information to validate the regulations are being followed. The farmers don't have an additional cost there, and they can continue using the same technology for their business purposes. I would argue to the regulators that if they want compliance and if they want to encourage ag technology, that the regulators ought to subsidize the purchase of all this equipment, or at least partially subsidize it as part of meeting the regulatory demand. This goes back to where we started with all the slices. Another way to look at it is there is obviously a rural-urban connection with all of this, and that's another driver. So if I turned that chart around this way, you can see it if you look over to the left where data analytics, agrilytics is. You've got on the bottom, you've got the farm field where it's coming from, the agrobotics, the robots on the farm, but on the top, you have the data centers, sensor-centric ag, which is where we're going, and these ag tech clusters which can be developed, including in this area, as part of that. If you go over, you've heard about telemedicine, telehealth, I won't talk about that, but in the middle, this IT-driven design and production, this is a very new trend that's entirely dependent on broadband. Because what is happening now, I talked about all those industrial jobs that disappeared, and there's a new trend which the Pennsylvania Department of Commerce talked about. I heard about this the other day. They're saying that there's the potential for a new kind of rural manufacturing based on small manufacturing, and it's based on the fact that you can, the high-tech or high-performance computing capability that's based in the cloud enables this kind of simulation for small batch manufacturing, and that what they call additive manufacturing, which is basically it's taking a 3D printer to the next level, is the basis of this new kind of manufacturing that is out there, that's coming, and then you use the cloud to run all of this. It opens the door for someone who has the tech savviness to have a very small manufacturing outlet that could do one-off production and be economical. So the requirement for these massive, you're going to produce 1 million units of things, this is the alternative to that. And it's the perfect alternative for rural areas, as long as you have the high-speed, high-capacity broadband. I talked to someone last week, and they were talking about an industrial park in Tehama County, which would be perfect for this if they have the broadband. They had this parcels divided out in an industrial park, about 10 acres each. It would be perfect for something like that. So where's the future? Well, I can't get in a time machine and go forward, but you could go to Holland, and maybe the future is there. And so there's a great National Geographic article in September of this year, which if you have a chance, you can look it up on the website and read it and take a look at it. And they looked at a slice where the Dutch have gone in agriculture. So one of their innovations is this rotary, I don't know what to call it, this rotary milking thing. And that's rotary cow operation. The other part, what they've done in Holland is, it's not a very big country, but their agriculture is, what they've done is they've gone into greenhouses. And so instead of the field, you see acres, hundreds of acres of greenhouses is where they've gone. And this is a high-tech broiler house that they've got there. And here's a view of all those greenhouses at night, because you see the LED lighting at night. That's where they've gone. And here is a entirely new thing. They're using microalgae, which they think could be the next food source for us, the next sort of input into your processed foods. But they're doing that. So that's the future over there. Now, let's talk about how time can travel faster instead of what Einstein said. And one of the things that has happened is if you look at the time it takes for innovation to go from invention to commercialization, it seems to be getting shorter. The illustrative thing here is the silicon chip. 1954 invented, was 2005, 50 years before they really got the payback there. The lithium-ion battery, 1991 to 2010, that's less than 20 years. There's other things happening. This is in the renewable energy side. But if you look in ag, it is speeding up if you look at it. So all this stuff, the pace of change is going faster, the new technology. This is a way of saying that there's two sides of this. One, the pace of new developments in agriculture has speeded up, so the cycle is much faster. So when you're designing a broadband system for this area, and there's new ag technology coming, the hardest part for you to imagine is to imagine what's going to be in the future and design a system that can accommodate it. Remember, when the internet was created, they had no idea there was going to be a Google or Facebook or any of that stuff. It was designed for communications between US government research facilities. Sort of not that exciting. And someone talked about tomatoes, so let's talk about tomatoes in the future. This chart shows you the productivity comparison across the board with the major tomato producing countries. The US is third, but the top, it's so high up there, it's kind of like Gabe's map with speed. It's so high up, it's just like out of sight on the scale in terms of productivity of tomatoes in Holland. So why is that? Well, here's the comparison if you look at the numbers. They have 6.9 square miles of tomato production. The US, or California, has 510 square miles. The US, or California, has over 14.8 million tons of tomato production. It is the large tomato producer in terms of quantity in the world. Smaller amount in the Netherlands, 992,000 tons. But look at the difference between tons per square mile. 144,000 tons per square mile production in Holland versus the 29,000 tons per square mile here in California, when you look at those numbers. And look at the difference. California, 15.2 gallons of water used per pound. Netherlands, 1.1 gallons per pound. The difference, field production versus greenhouse production. I'll oversimplify it as to that. But that's where they've gone. That's their future. This graphically illustrates the comparison in the amount of water used. 92% less water per pound used. Now, that's relevant for here because say a drought comes back. Say they don't deal with all the water issues in the state. That information is pretty useful to have if you want to continue to grow tomatoes in this area. And those greenhouses all have high-capacity wireless broadband in the greenhouse. And they're flying drones around in the greenhouse so that this is a piece potentially of the future to look at. It's already showed up in Holland. So it's something to think about. And so I'll end here. When I was here last year, I had that part, the future as being in West Hills, Coalinga. And I'll say here is you have the opportunity to build the broadband highway to the farm as captured by that graphic there. So thank you.